Final example here, 42.3. Use scientific notation to help estimate the answer to this problem. 0.0418765 times 10 to the negative 14th, 41,725 times 10 to the 43rd, and 9,764 times 10 to the negative 23rd. So, start off with this one. This is going to become 0.04 times 10 to the negative 14th power. Again, one non-zero digit. All that other stuff, 18765, doesn't matter. All right? It's closer to 0.04 than it is to 0.05. That's what we're going to put for that one. Then we're going to, 41,725 is pretty close to 40,000. That's times 10 to the 43rd power. And then we have 9,764, which is pretty close to 10,000. And as far as underestimating, overestimating on something like this, to get an idea, because when there's multiplication and division, it's kind of harder to tell. But I made this a slight bit smaller, right? And that's a really tiny number to begin with. It's 10 to the negative 14. So there's already 14 more zeros in front of that zero. So I just chopped off like a quadrillionth or something like that, maybe even less than that. It's not a whole bunch. So that's almost exactly the same number. That's irrelevant. Okay, the amount of discrepancy there is not going to matter that much. This one here, this is 40,000. We made that bigger, right? Made this bigger, a lot bigger really, because that's 1725 times 10 to the 43rd power is a pretty large number, okay? And then we made this a little bit bigger too, right?
How did we make 41,000 bigger? I thought we made it smaller.
Oh, we did. We made this smaller. We made this bigger. Okay, sorry. We made this smaller. So we got smaller and smaller on top, and we got bigger on the bottom. Think about how fractions work. The top got smaller, that gets the overall value smaller, right? The bottom got bigger, that makes the overall value smaller yet still, right? So like for example, if I have 1 divided by 2, that equals 0.5. If I have 1 divided by 3, now it equals 0.33. If I start making the bottom number bigger, I'm making the overall value of this fraction smaller. So smaller, smaller, and then bigger on the bottom makes the overall value smaller. So altogether, the answer we get here is going to be smaller than the right answer. And again, just know that. I mean, rounding up, rounding down, I mean, again, that's up to you. I'm not going to put that much thought into it. Use the technique I'm telling you to use to get the answer. Just know that if you're actually evaluating this to get the exact answer using your calculator, we're getting an underestimate, so the answer we get should be bigger than that. That's the main idea of what I want you to be able to do. All right, so let me pick on Lexi because we just talked about this. Fix this blue one here to scientific notation form.
So it'd be 4 times 10 to the negative 12?
Okay, let's go here. Again, in this,
Oh, would it be 16?
well, let's look and see what it should be. Okay, so we start off with negative 14, right?
Yeah.
And we made this bigger, right? So we should add or subtract.
Oh, subtract.
Subtract. And again, if you look at it, you can see what you're supposed to do. And what should you do here?
You should
Should you add them or subtract them?
add them.
Because the signs are the same, right? So again, if you're not, obviously -2 is what you're supposed to do, but then should I add or subtract the numbers is based on the signs and numbers you're looking at.
Okay.
These are the same, so we add. So negative 16 is what we should get. All right, let's go with Austin. What about the red one? 4 times 10.
Well, you got to move the decimal over 1, 2, 3, 4.
Okay.
So then you add that to the power. So 4 times 10 to the 47.
Perfect. 4 times 10 to the 47 power. We made 4 decimal place change here, making that smaller by 4. So we take the power we had and we're going to add 4 to it. 43 plus 4 makes 47. Exactly right. Let's go with Delilah. 10,000 times 10 negative 23rd.
You have to move the decimal 4 places over. You do negative 23 plus 4.
Okay, so we're going to get 1 times 10 to the
19. Negative 19.
negative 19. Perfect. Okay. So again, that's the second thing. Change everything to scientific notation correctly. And again, if you're unsure of what the power of 10 is supposed to be, if you know what you're supposed to do to make it happen at least, and you can write it on your paper, then you can use your eyes to determine add or subtract. Same add, different subtract. The bigger number always determines the sign of the answer. Then, at this point, 4 times 4 on top is 16. And then the power of 10, negative 16 plus 47 is going to be 31. 1 times nothing is 1, and negative 19 plus nothing is negative 19. So we get 16 over 1 times 10 to the negative 19, or 16 times 10 to the 31st. 16 over 1 is equal to 16. And 31 minus negative 19. Again, it's always top minus bottom. Write down what you're supposed to do. Minus means plus, so it's going to be 10 to the 50th. That's 1.6 times 10 to the 51st. Very good. We're going to move this 0.1 space over, making it smaller by 1, so we have to add 1 to that to make that 51. And then again, round it, 1.6, that's going to be 2 times 10 to the 51st. And again, that'd be a situation, if it was 1.5, I'd want to go up. Obviously going up to 1.6, I'm going up. That fixes it a little bit. I'm going to say that's probably pretty close to the right answer. But again, everything was smaller, so we're going to be an underestimate world. If we round up, we're going to get closer to the right answer, but not exactly.